Dr. Babasaheb Ambedkar Open University.
Good morning, dear students. Today we are going to start with our first block and first unit of software engineering. Block 1 is introduction and unit 1 name is introduction of software engineering. So on your screen you can see our agenda of the unit, like learning objectives. Then we will go for introduction. Then we will see a role of software, then types of software, then we will see software engineering, a layered technology. Then we will also see a process framework, and then we will see umbrella activities, then a capability maturity model integration, CMMI. Then let's start with learning objectives. So the objective of the chapter is to introduce concept of software engineering and related terms. When you will learn this chapter, then you will be able to understand what is software and types of software. Then you will get insight of software engineering, then actually process related to framework and umbrella activities, and also you will gain knowledge about capability maturity model. So let's start with introduction. Actually, computer software is the product that software engineer build. It encompasses programs, database and documents. Nowadays, computer software is included in majority of the products, right? So it has become pervasive in commerce, culture and our everyday activities. So a textbook definition of software can be: software is set of instructions or programs that when executed provide a desired feature, function and performance. Or we can say data structure that allows program to adequately manipulate information. And also we can say documents that describes operations and use of programs. Now we will see role of software. So software serves dual roles. It is a product as well as a means to produce a new product. As a product, it allows users to utilize computing potential of computer hardware. So as a product, software transforms information through various processes. So it acquires information from various input sources. Actually, it manages information by performing processes on it, such as sorting. It produces information as a result of processes. Then it modifies information to the needs of users. So it formats information for display, and actually it transmits information through network also. So this information can be a simple one bit of data or can be a complex like multimedia presentation. So as a vehicle to deliver product, software controls hardware, then it controls communication of information over network, and also it allows creating and controlling other programs. Actually, software delivers most important product of time, the information. Actually, it transform personal data, manage business information to enhance competitiveness. So it provides gateway to worldwide information networks. So role of computer software has changed tremendously over span of more than 60 years. So we have seen tremendous improvement in hardware performance and its computing architecture over the years. Size of its memory and storage devices has improved drastically. It offers variety of information and output devices. This all has resulted in a more sophisticated and complex computer-based system. But such tremendous changes are not seen in the ways software are being built and delivered. So many questions arises over here, like why does a software need longer time to finish, right? Then why are software development costs so high? Then we have questions like why finding errors before delivering software to customers is still impossible. Then why maintenance of existing software requires so much time and cost. Why we face difficulty in measuring software development and maintenance. So we have these questions have led to adoption of software engineering practices, right? Now let's see types of the software. So information content and information determinacy determine type of software applications, like system software. Then we have application software, as you can see on your screen. Then we have engineering scientific software, and we have also embedded software, then product line software. Then we have web applications related softwares. Then we have artificial intelligence related softwares. We have net sourcing. Then we have open source software. So these all are the types of software. Then at last we have the new economic software, then system software. So let's start with describing this all the software. So first one is system software. So these are the programs that service other programs such as operating system. Some operating systems process complex and determinate information, whereas some operating system process indeterminate data. So the characteristics of such operating systems are heavy interaction with hardware, multiple user, concurrent operations that require scheduling. Then we have resource sharing, process management, then complex data structure and multiple external interface. Then second one is application software. So these are standalone programs that solve a specific business needs. Such applications facilitate business operations and decision making. Some software are also used to control real-time business function. For example, point of sale transaction processing, then real-time manufacturing, etc. Then the third one is engineering scientific software. So this software can be characterized as a number crunching algorithm which range from astronomy to volcanology, from molecular biology to automated manufacturing. So some examples of these softwares are computer assisted designing, CAD, CAD, weather forecasting systems, etc. Then we have a next software related with embedded software, right? So in embedded software, these software reside within a product or system. They are used to implement control features for end users. They generally have limited functions. Then we have product line software. Such software provide specific capability for use by many different customers. This software address mass consumer markets, for example, word processor, then spreadsheet, etc. Then we have web applications. These are wide range of applications stored as set of linked hypertext files. Nowadays, web apps give sophisticated computation by integrating corporate databases and business applications. Then we have artificial intelligence software. This software uses non-numeric algorithms to solve complex problems that that problems cannot be solved by computation actually. So applications include robotics, expert system, then artificial neural network, etc. Then ubiquitous computing software in which a rapid growth of wireless networking has led to distributed computing. Actually, they pose challenge to software engineers to develop such systems that allow small devices and computers to communicate across a vast network. Then we have net sourcing. So World Wide Web has become a computing engine and content provider both actually. So there is a need to provide simple and sophisticated applications benefits targeted and users worldwide. Then we have open source software. So a policy of distribution of source code for system applications to customers has made source codes available for local modifications nowadays. So software developers need to build self-descriptive source code along with techniques that allow users to know what changes have been made to the software. Then we have the new economy software. And in the new economic software, the .com economy lead to new applications that facilitate mass communication and mass product distribution. So in the next slide, we will see software engineering, a layered technology. So here, according to Frisboer, software engineering is establishment and use of sound engineering principles in order to obtain economical software that is reliable and works efficiently on real machine. According to IEEE developed a more comprehensive definition, which is like software engineering is the application of a systematic, disciplined and quantifiable approach to the development, operation and maintenance of software. For example, the application of engineering to software and the study of approaches as in software engineering is a layered approach. So in the next slide, we can see the 4 layers of software engineering, where layer 1 is tools. So the first layer involves choosing the semi-automated and automated tools that will become the framework for the project. Some examples may include like choosing Microsoft Publisher for web design. Then we can say using Selenium for testing across platforms. Then the third one is using an integrated development environment for building applications. Then layer 2 is method. So the second layer establishes the methods of developing software. This includes any technical knowledge and resources required for development. Some tasks include choosing method for communication, analysis, modeling, then program, construction and testing, and we can say support also. Then in the layer 3 process, layer 3 focuses on the framework that needs to be established to deliver software effectively. This layer can be broken into 5 sub layers like communication. Let's define. Various facts of communication are needed at this point, and in fact they are critical to success. First, communication with the client is required to understand needs, demands, criteria and parameters of the project. Team communication disseminates this knowledge so that everyone is on the same page. Ongoing communication prevents actually misunderstanding and wasted man hours. Then we have planning. So this sub layer involves making a map or blueprint to break down the process of development and document goals, milestones and plans. Then we have modeling. For this part of the process, developers create a model. Actually, developers create a model so the client can visualize the finished product. Then we have construction. So these sub layers refers to the actual coding and testing of the product. Then we have deployment. So this differs from modeling. Rather than just providing the client with a model, the team delivers an actual version of the software for testing, evaluation and feedback. Then layer 4, a quality focus. At this point, the software is developed and refined to a point, but it is critical to apply quality control to the finished product. Besides testing the end product to ensure that it meets the client's specification, it also needs real world testing to determine how efficient, usable and reusable it will be, and it needs to explore how many resource maintenance will require actually. So, if it is replacing an older software or platform, quality control will ensure the new software will meet the needs. We have some questions like why use the layered approach? Then the answer will be laying out the tools, methods and processes from the start of the software engineering process, and then actually communicating these decisions to the development team allows client, project manager and team members to periodically test the quality and usability of the end product, right? So, the layered approach allows a team to deliver even complex software on budget and on time. Now, the second question may be like benefits, what are the benefits of software engineering as a layered technology? So, the answer can be like this. Since software demands are getting more complex, the layered approach offers some important advantages and benefits. So, those advantages can be better decision making. Actually, let's define. So, the decisions outlined in each layer provide a structure for the whole project. So, unifying collaboration and problem solving. Then, second advantage can be early error detection. So, the layered approach lends itself to identifying and solving errors early in the project. Then we have ease of configuration and maintenance. So, the helpful feedback, timely testing and constant communication help to make the end project easy to configure and maintain. Then in the next slide, we have process framework, right? So, software process to build any product, a series of predictable steps, a roadmap are designed, right? So, it is called a process. Same applies to software. Software process helps achieve timely, high quality result. It consists of a framework for tasks that are required to build high quality software. So, a process framework creates the foundation for software process. It begins with identifying framework activities. So, these activities are applicable to all software projects, right? So, the framework also encompasses a set of umbrella activities that are applicable across entire software process. Each framework activity consists of a number of software engineering tasks, accomplishes some part of the software. So, in the next slide, we have a majority of software follow a generic process framework consisting of communication, planning, modeling, construction and deployment, right? So, in the communication phase, actually it refers to communication and collaboration with a customer for requirement gathering, right? And the planning actually, so these activity refers to software engineering work plan to be followed actually. It deals with technical tasks, schedule, resources, risk associated with software, then work products to be produced, etc. Then in the modeling, actually it consists of analysis and design. Analysis creates analysis model. Then design models is created from analysis model. Design model enables developer and customer to understand software requirements and if design will achieve it. Then construction refers to code generation and testing either manually or automated. Then we have deployment. Completed software is delivered to customer who then evaluate it and provide feedback. So these 5 framework activities are applicable for the development of a small project or a large and complex computer based systems alike. Then in the next slide we have umbrella activities. So on your screen you can see umbrella activities. All framework activities are surrounded by umbrella activities. Umbrella activities are applied throughout software project. If applied systematically, these activities ensure successful completion of project. So in these activities we have tracking and control, then we have technical reviews, we have quality assurance, then you can see on your screen configuration management, then we will have documentation, then reusability, then measurement and metrics, then risk management. You can see a diagram also on your screen. So now let's define each activity in brief. So we will start with tracking and control. So the developing team accesses project plan against predefined schedule, right? So if they find that the project is not going according to predefined schedule, then necessary actions are taken to maintain the schedule. Then we have technical reviews. Actually, the aim of technical reviews are to detect quality problems and suggest improvements, right? So the technical person focuses on the quality of the software from the customer point of view. Then we have quality assurance. In the quality assurance is conducted assess software quality. For example, during the software development, meetings are conducted at every stage of the development, actually to find out the defects and suggest improvements to produce good quality products or software. Then we have configuration management. So this activity manages the effect of changes throughout the software process. Then we have documentation. So these activities that are needed to create the documents, forms, lists, logs and user manuals for the software being developed. Then we have reusability. So here this activity defines the specification for reuse of the products. It also set up a mechanism by which reusable components are developed and used. Then we have measurement and metrics. So software can be measured directly or indirectly. Direct measures are line of code, cost, etc. Then indirect measures are quality, functionality, etc. This activity defines how software can be measured and using which metrics. It also helps develop new metrics for developers. Then we have risk management. Risk is an event that may or may not occur. So many risks are associated with any project, right? This activity assesses if risk may occur, and if they occur, how it will affect project. So in the next slide, we have capability maturity model. So the capability maturity model integration or CMMI is a process model that provides a clear definition of what an organization should do to promote behaviors that lead to improved performance, right? So with 5 maturity levels, the CMMI defines the most important elements that are required to build great products or deliver great services, and wraps them all up actually in a comprehensive model, we can say. Now CMM examples can be people CMM. Let's define. Develop in the people CMM, develop, motivate and retain project talent can be considered. Then in the software CMM, enhance software focused development and maintenance capability can be considered. Now in the next slide, we have maturity level 1, which is performed, right? At this level, processes are usually ad hoc and chaotic. The organization usually does not provide a stable environment and do not use any proven processes, right? Such organizations often produce products and services that work. However, they frequently exceed the budget and schedule of their project. Then characteristics of such organization are a tendency to overcommit, then abandon processes in the time of crisis and not be able to repeat their past successes. Then in the maturity level 2, we have managed. So at this level, an organization has achieved all the specific and generic goals of the maturity level. Actually maturity level 2 process areas. Then projects are performed and managed according to their documented plans. Then organization ensure that project requirements are managed and that processes and work products are planned, performed, measured and controlled. Then work products are reviewed with stakeholders also. In the maturity level 3 defined, at this level, processes are well characterized and understood and are described in standard procedures, tools and methods. At maturity level 3, the standards, process description and procedures for a project are tailored from the organization's set of standard processes to suit a particular project or organization unit. Now the organization's set of standard processes include the processes addressed at maturity level 2 and maturity level 3. So as a result, the processes that are performed across the organization are consistent except for the differences allowed by the tailoring guidelines. Processes are managed more proactively using an understanding of the interrelationships of the process activities and detailed measures of the processes. So actually it works products and its services. At the maturity level 4, which is quantitatively managed. So at maturity level 4, sub processes are selected that significantly contribute to overall process performance. These selected sub processes are controlled using statistical and other qualitative techniques. So qualitative objectives for quality and process performance are established and we can say used as criteria in managing processes actually. So quantitative objectives are based on the needs of the customer, end user, organization and process implementers actually. So quality and process performance are understood in statistical terms and are managed throughout the life of the actually processes. For the processes, detailed measures of processes performance are collected and statistically analyzed. Quality and process performance measures are incorporated into the organization's measurement repository to support fact-based decision making in the future. Then maturity level 5, which is optimizing. So at this level, processes are continually improved based on a quantitative understanding of the common causes of variation inherent in processes. So focus is on continually improving process performance through both we can say incremental and innovative technological improvements, right? So through quantitative process improvements, changing business objectives are revised. Then improvements in processes are measured and evaluated against the quantitative process improvement objectives. Then optimizing processes that are agile and innovative depends on the participation of an empowered workforce aligned with the business values and objectives of the organization. The organization's ability to rapidly respond to changes and opportunities is enhanced by finding ways to accelerate and share learnings. Improvements of the processes is inherently part of everybody's role, right, resulting in a cycle of continual improvement. So each maturity level provides a necessary foundation for effective implementation of the processes at next level. So higher level processes have less chance of success without the discipline provided by lower levels. Now the CMMI defines each process area in terms of specific goals and specific practices required to achieve these goals, right. Now to achieve a maturity level, the specific goals and associated practices must be achieved. In the next slide, you can see the table of CMMI levels with process areas and result. Here you can see different levels, like level 5 optimizing, where focus is on continuous process improvement. Then process area is organizational innovation and development, then continuous analysis and improvement, and the result can be highest quality and low risk. So the same in the level 4, which is quantitatively managed, you can see in the focus column quantitatively managed, and in the process area column organizational process performance quantitative project management, and in the result column you can see higher quality or lower risk. For the level 3 defined, you can see in the focus column standardization of process, and the process area can be requirements development, technical solution, product integration, verification, validation, organizational process focus, organizational process definition, organizational training, integrated project management, risk management, decision analysis and resolution. And in the result column you can see medium quality, medium risk. In the next slide we have level 2 managed. In the next column you can see focus column basic project management. Then we have requirements management, project planning, project monitoring and control, supplier agreement management, measurement and analysis, then process and product quality assurance. Then at last we have configuration management, and in the result column you can see low quality or high risk. Then for level 1, which is performed, in the focus column we can see process is ad hoc and informal. Then in the result column we can see lowest quality or highest risk. So after completion of each and every topic, my dear students, let's sum up this unit. So actually software is the key element in any computer based systems. Over past 60-70 years, software has evolved, yet we still have trouble developing high quality software. The intent of software engineering is to provide a framework for building higher quality software. Software engineering is a discipline that integrates process, methods and tools for development of computer software. So whatever the size and complexity of a project, all must undergo a definite process. Each process has a defined set of framework activities, right? So each framework activity is covered by a set of umbrella activities that span entire process. So the capability maturity model integration is a model that describes specific goals, practices and capabilities that should be present in mature software process. So this is all about unit 1, my dear students. We will meet for unit 2 of software engineering. So till then, have a great day.